Hey all, welcome to my YouTube channel. So in this class we are going to discuss few more graphs and we are going to start in the classification of semiconductor. So let's begin the graphical significant representation understanding for the drift velocity with the electric field. So x-axis we can take as electric field and this y-axis will be drift velocity V of t. So based on the increasing the electric field, how the drift velocity vary, that thing we are going to see. So let's take the two standard value 10 power 3 and 10 power 4. So first what will happen is that the drift velocity will be keep on increasing, like it will increase up to 10 power 3. Then after the 10 power 4, it will be sustaining. 10 power 4 is the threshold of sustaining. So in this in between gap, what will happen is that there will be a transition of curve. Like this way it will be transitioning. So this is what the 2 point of reference where everything will take place. So up to this. So this is the two curves. Okay. So this is 10 power 3 and this is. So VD which is directly proportional to E in this case, in this region of a curve. So after that there is one small drift changes and then it will be stabilizing. So why this is happening is that in this region, like in the first region and this is second region and this is in the third region. So in the first region what will happen is that in this region electric field is increasing. So that what happen is that kinetic energy of electron will also increases. The kinetic energy of electron will also increases. Hence the drift velocity will be keep on increasing. In the second region, like in the 10 power 3 to 10 power 4, like when there is a region of 10 power 3 e to 10 power 4, the same thing, the electric field is increasing, the kinetic energy is increasing, but due to collision of electrons, here there will be more collisions, right? So due to collision of electrons, some energy, some amount of energy is released in the form of phonons, like heat. Some amount of energy is lost in the form of phonons, and some amount of energy is lost. That lost is called phonons or heat. Usually we mention as phonon, that is h nu. So that is lost in the form of 3. In the region 3 also same. So region 2 is responsible similar to that of region 2. So this is one type of curve. Like mobility is another one important term. Like mobility, how the mobility will decrease with respect to E. So unit of E is V by that length we can take here a centimeter because electronic devices we take a centimeter. So mu. In first few instant it will be constant. So here also time 10 power 3, 10 power 4. So here it will reduce to one jump and then another one jump. So this first dip is 10 power 3 and the second dip is 10 power 4. So here this is constant. So here in this curve the mobility will decrease in the square root of E, like decreasing in the term, but here it will decrease directly proportional to e power minus 1. So this is 10 power minus 3 and this is 10 power minus 1. So these are some kind of research and analysis which is made in lab. So we need to just remember how these things are behaving in different things. Okay, so I hope this is very good understanding for you guys. So now let's begin into the next understanding. Like this is a new topic, all the prerequisites are completed. So now this is classification of semiconductors. So now only we are getting into an interesting topic, classification of semiconductors. So first thing we are going to take is the pure form. There is no doping or nothing. Second thing we are going to take is the intrinsic. There is a pure. The doping is intrinsic and eccentric. Both we can take it. The doping is come into picture here. It's intrinsic and extrinsic semiconductors. And the third type, which is called as the elemental or componental type. Elemental. We are going to discuss everything detailedly. Elemental and componental type. Compound type. Then another one thing is that direct and indirect semiconductor, band gap semiconductors. This is an important thing. Direct and indirect band gap semiconductors. Okay, so this is the entire classification of semiconductors. So we will be discussing everything detailedly. So in this class, let's start with the pure. So pure is basically nothing but it's a practically difficult to and found. So this is pure. The semiconductor which is pure, we can't practically get it. So which is a pure semiconductor. Practically we can't find, because everything in this world is like impurity, or that ideal thing is not there, right? Similar to that, the pure semiconductor is not practically difficult to found. There is an intrinsic semiconductor which is coming to picture, as grown by some methods, like we will be forming this one, like intrinsic semiconductor will be formed by some CZ process. So these are some semiconductor manufacturing processes. So that all are not needed in our thing. So what they will do is that they from polycrystalline silicon they will make as a crystalline silicon. From polycrystalline silicon, and they will make a crystalline silicon. So this is some kind of process they will be forming. So there is many other different kind of process are there happening. So how the extrinsic and how other things are made. So the things we will be discussing from next class. So the semiconductor manufacturing process, like IC fabrication, we will be discussed at last, because in most of the exam and most of the syllabus they are removed it completely. So based on the responses, we'll be discussing about those things. So from next class, let's start with the extrinsic semiconductor, where N type, P type, the doping and everything will be coming into picture. So like, share and subscribe the channel. If you guys have any doubt, please ping in the comment section. I will for sure will rectify it. Thanks.